first of all?
Yes.
All right. Thank you, Dr. Rucci. Thank you, Amit, for the introduction. Um, my name is Luca Santini. I'm originally from Switzerland, or better said, from the cold Switzerland, since last night it's been covered everywhere with snow. I'm the head of sales for Swisstrons, well, actually the manufacturer of the UAV you see in the background here. I joined the company May last year in 2020. The company has been focusing on the development and manufacturing of the unmanned helicopter. Since 2013, we already provided to the market more than 30 units in 12 different countries. Today, I will be showing you a quick company introduction and also product introduction, and then I'll jump more into one of our main use cases and one of the most successful also lately, which is the power line inspection. Amit, should I share my presentation, my screen, or will you share the presentation?
Yes, sir, you can share.
All right, perfect. Then let me just. Okay. Can you see the screen?
Yes, sir, we can.
Perfect, perfect. So as I mentioned before, the company has been founded in 2013, always focused on the development and manufacturing, and also since last year on the operations on the unmanned helicopter, basically focusing on the European geography, and then in the rest of the world, we mainly cooperate with service providers, with our business partners. The company is based in Switzerland. We have our head office in Zurich, and we also have a manufacturing site in the eastern side, close to Liechtenstein or close to Austria, if you want, in the small city of Bux. We are dedicated to the Swiss aerospace cluster and quality, and as I mentioned before, we already provided more than 30 units in 12 different countries. Just a quick overview about the product. Mainly the unmanned helicopter. As you can see also from the sides, we're talking about either a big drone or a small helicopter. It is an unmanned helicopter with a 3 meters diameter. You see also on the picture on the right hand side. We're talking at 3 meters diameter side, so it's kind of a pretty big drone than the usual one you may have seen on the market. We're also focusing on beyond visual line of sight operations only. Also, thanks to the sight and the payload capability, it doesn't make sense to have BVLOS, visual line of sight operations only. The payload capability or capacity is up to 40 kilogram, including the fuel. And also it has an operational range of more than 100 kilometers. We have an integrated autopilot system, which basically enables you to pre-plan missions and fly them automatically, also from takeoff to the landing. And also we can integrate different type of sensors. As you can see also in these pictures, we have every time a different type of sensor, depending on the use case and on the customer requirements, which might be from an inspection or area surveillance or search and rescue mission, for instance. Here, a very quick overview of our technical data. I don't want to jump in this one. I just put it there so that later when they will share my presentation, you will be able to go through more in details. And if you have also any following question, I will be more than welcome to go through more in the technical details. Here, an overview of our main applications or verticals. Well, area surveillance has been one of our first use cases that we have been doing. We started a lot in Asia, especially, which is mainly flying with a gimbal or a EOIR stabilized camera for any type of surveillance. It can be, well, for instance, for natural disaster support after, for instance, a hurricane or after floods. It can also be during wildfires, for instance. Or simply for the police, an eye in the sky, just to have an overview of the situation from a site which is far away from the site, the point of interest. Search and rescue is very similar, just in this case, thanks to the high payload capability, we can carry also additional devices, which could be a life rescue device. It could be, for instance, for a search and rescue mission in the maritime environment could be a self-inflatable jacket, which we can drop in the water. The person can stay there until a vessel or a manned helicopter comes to rescue them. So we support, in this case, more the search part. And last but not least is the inspection vertical, in which we have some sub-verticals. Today, I will focus more on the power lines. As also you can see in these pictures, we focus a lot also on pipeline for the oil and gas industry. We focus also on the railway, and I'll jump here in the next one. So you see the power lines, the pipeline for the oil and gas, the railway, and also on the civil protection for nuclear power plants and monitoring and inspection. So this is one of very nice pictures that we took. This was in Switzerland, where we did a power line inspection. In this case, I will show you also the main requests or requirements from the customers. Not only this, but these are the main requirements from defect detection to 3D models and corridor mapping and corona effects pictures. In the first one, in the defect detection, we mainly use RGBs camera or as well IR cameras, infrared cameras, where the customer has to find, for instance, wants to find the defects they have, which could be like the top one left, cable strands or corrupted spacers, the one on the right side, or on the bottom left is a bird nest, or even a missing insulator on the right one. In the center one, the 3D model and corridor mapping, there you have some example. Usually you do this type of missions with a LiDAR sensor, and then on the last one, the corona effect, you apply with a UV camera, which is simply able to find the discharge on the power lines. Now I would like to not only show you some of these pictures, nice picture, but I would like to show you more how the solution is really working. And in this case, I even put a video, a link to a video that you can access later. This is actually a customer video that they created, so it's better let the customer talk about the solution. I just will tell you more about the solution and how the results look like, but then you will have time to go through the YouTube video as well later on. In this case, on the left picture, you see how the solution looks like with the cameras, which are basically two phase one cameras of 100 megapixel, one phase one camera of 150 megapixel, two infrared FLIR cameras, and then also a mini computer device for automatic triggering during the flight. Basically, the customer wanted us to fly next to the power line, non-stopping, and triggering pictures and get the result that is actually looking for, which means having a 1 to 2 millimeter GSD. And I believe the expert here in the call who knows about RGB's camera know how difficult it is to get those type of high quality pictures, especially while moving, where we're flying at a minimum speed of 5 meters per second, 18 kilometers per hour, and triggering the cameras and taking this picture. So that we were basically able to find the defects that were described here on the left-hand side in this slide. And this was a project in France that you will see, or you will find also on the link. I'll go through more the results, so you see also the quality that we can really reach that quality. This is basically the picture. We're talking of picture of the size between 100 and 200 megabytes. So it's very, very big picture. Plus, you also need to be able to store all of them while you're flying, especially if you're flying 100 kilometers in one flight. You need to store, at one point you get to terabytes of pictures, of data that you still have to be able to store during the flight. So it's pretty an interesting solution. And here is the result. You see, while you zoom in, you can see also the details that you can find on the insulators, for instance, in this case, or this one, for instance. This is the full picture for the 150 megapixel camera. And you see, you can still zoom in and have pretty good results on the foundations of this tower. Then here, going forward, you will see, if we zoom in, we're still capable of detecting, in this case, a bird nest. Now, all these pictures I would zoom in, at the end, until now, there were people going through every single picture, zooming in and trying to find its defects. Nowadays in the market, there are some software, which maybe you already heard of or being using as well. that are capable of finding these defects automatically. There are AI software which has been taught in the last 3 to 4 years, going through models and defects, and then capable of finding these. And this, for instance, this bird nest has been found by this software, not even by people looking at it, by the software automatically. So it's the current situation is getting better and better also to automate this whole process in the analysis of the pictures. Going forward, this was, and also here another link for another customer for an inspection in Belgium, a power line inspection with LiDAR for creating the 3D model of the whole power lines. We're talking about a 100 kilometers, more than 100 kilometers in one flight as well here. With this Yellow Scan Explorer LiDAR, is a brand new model they just launched. They launched this year on the market. You see it integrated under our UAV in this case, and these are the results which has been created during this flight. And here again, you will have the capability to see the link, the video in YouTube done by the customers in this case as well. In this case as well. So this would be it from my introduction. I hope I gave you an introduction with some answers and some interesting solutions also for your potential projects.
Thank you, sir, for an amazing presentation. Now the Q&A session can take place. So if you have any questions, comments, and compliments, please drop in the chat. Meanwhile, sir, there's a question. So at the very start of your presentation, you mentioned that your company mostly works over helicopters. So that like created a curiosity in my mind. Why did you choose helicopters over other multirotors when you had the other options left?
I'm not sure I understood the question properly. Can you repeat that, please, Amit?
Yes, like you mentioned in the starting of the presentation that you generally have helicopters for your work. So I would like to ask, why did you prefer helicopters when you had options of other multirotors? Oh,
sure. Well, basically, we have to see also how the market is currently. We have the options of, if you look at the whole market of the unmanned solutions, you have from small quadrocopters, which are able probably to carry between 1 to 5 kilograms and flying maximum around probably between 30 and 45 minutes. Then you have new solutions of VTOL, fixed wing VTOL solutions that can carry probably 1 to 3 kilograms, but they can at the end fly pretty long time because they have simply these VTOL capabilities. When we don't have a runway, so then you can fly a long time, but with a very small payload. Then you have our category of simply unmanned helicopter, I would simply call it, where we can carry 40 kilogram. And at the end, we are still capable of flying currently 3 hours. We're developing a new solution which is going to double this time in the air. And then you have very big unmanned helicopter or unmanned fixed wing, but they are usually most used in the, I would say, military. We're focusing only on the civil applications. So our goal is to well, basically replace the helicopters, the manned helicopters, in the missions that are dangerous for the manned helicopter. As you probably know, in the power lines inspection as well as pipeline inspections, every year there are a lot of accidents, unfortunately, with dead people as well, or dead pilots, or the whole flight crew. And this is exactly where we're jumping in flying those missions for the power lines, for instance, where you fly next to 400 kilovolt cables or power lines. And we want simply to replace those type of missions, helping also the flight crew to reduce their risk and also reduce their cost at the end. And the same is for the surveillance missions, or even for firefighting missions, where basically, for instance, here in Switzerland, they are not allowed to fly during the night with helicopter. And you always want to use also the helicopter for the type of mission, rescue, for instance, and not for some preliminary surveillance or reconnaissance. So in that case, we jump in, flying in the night and flying those missions, which could be dangerous in that case. And just to also complete the answer, I still believe that the small quadrocopter solution will be very useful, especially also our customers. They are not only using our helicopter. We are not flying over cities, for instance. Small quadrocopters still give you the chance to fly next to a power line where you have to go for maybe more details, or if you just have to do short flights, for instance, with a small camera and just in 5 minutes take off and come back. These are still very useful machine. I don't think that this is a competitor for us, honestly. The small quadrocopters, for instance, DJI, but it's a complementary on those type of long range, or on the whole power line inspection or pipeline inspection, the whole inspection vertical.
So may I add up to this?
Excuse me?
May I add a point to this?
You sure?
Yeah, so even helicopters are mechanically complex, but electrically they are much simpler than the complex VTOLs or the multi-rotors. So the chances of failures are less in terms of helicopters.
Sorry, Amit, I'm not sure if the audio is not good. Can you repeat the question, please?
No, it was not a question. Rather, I added a point to the explanation that helicopters are less objected to crashing or something because they are mechanically more complex, but they have less chance of electrical failures as compared to the complex VTOLs.
That's for sure. Plus, even though I have to say other systems are also very well. As I repeat, it's just a complementary, and also our customer using both our system and fixed wing VTOL as well as quadrocopter. Just depending on the type of mission you need to use and what you have to do, you will simply use another system. Plus, I think also nowadays with very interesting technologies which is coming on the market for redundancies on the systems and so on, that will make not only our helicopter but also the type of platform much safer to fly than it was in the past.
Thank you. So, and there was another question in the chat which asks, have you ever used your helicopter for BVLOS missions, and what learnings did you get from those missions?
Yes, thank you for the question. Yes, we did several times. Basically, we're flying only in BVLOS missions. We are not focusing on VLOS missions. Again, maybe the quadrocopter or smaller drones are more useful for those type of missions. We're starting from, well, in Switzerland, for instance, the difference between VLOS and BVLOS is 500 meters, but we start from mission at least 10 or 20 kilometers far away. Our customer in China are flying Powerlines inspection at least 20 kilometers. We flew here in Europe already 100 kilometers, but over a stretch of, for instance, more than 10 kilometers. So our learning is simply that, well, safety first. It is very important to be safe when you're flying this type of missions. In fact, we were cooperating with several parties also from ATCs. We included a transponder, an ADS-B modest transponder in our system, that even when we are flying in CTR control traffic regions from the airport, we already had permission to fly in these regions, and we were able to cooperate with them and to communicate with them, and just making sure that there is no other aircraft entering our area or a flight area. And the same way, we're not flying in a controlled traffic region area. We were working with other companies who are able to show our system. We did some mission, just to give an example, more practical example. We flew missions where you were able to see our platform in Flight Radar 24. So you were able to access, you put in the number of our aircraft, you see it flying, so you see any other aircraft approaching it. So that also from a safety perspective is very important. I believe also from a regulatory perspective is still we are in a very early stage. In the future, there will also additional technologies will arrive, like detect and avoid, or sense and avoid, which will help to increase even more the safety.
Thank you, sir. I see David has raised his hand. Maybe he has a question.
Yeah, I see that. Yeah.
Hi, Luca. You must excuse me. I've got the flu. Yeah, I worked on a sabbatical at the German Aerospace Center, and we worked with your terrific platform, the Dragon 50, and many projects. It was called the Super Artist at the time. I was really hoping a while ago you were able to bring it out to the African Drone Forum, but we never got that sorted out. My question really is about the safety risk methodology, and I'm a member of the Joint Authorities on Rulemaking for Unmanned Aircraft Systems, for UAS, I should say. I'm initiating a new group through the Flight Safety Foundation, and I don't know how the the Swiss drones platforms go through the SORA methodology. However, the SORA methodology doesn't work that well in limited resource settings and the remote locations. So the Flight Safety Foundation group has taken on board some suggestions of mine, and we'll look at, for example, you mentioned ADS-B. ICAO is very much against ADS-B on small UAS, and I'm sort of promoting a position against that. We're also looking at an adapted safety methodology for the Global South. So, perhaps we could contact about that if your company's interested in that, please.
We're very interested also into new technology, and also seeing how the regulatory framework is going to work. Basically, what we are following also in our company, we flew, for instance, the mission I mentioned before of the 100 kilometers in Belgium. We wrote all our CONOPS based on the SORA, the JARUS, provided by JARUS. And in the other projects where the CTR area region I was mentioning, and close to the airports, they asked us to have a DSP, which we as a standard anyway, or as a standard, not really. If a customer doesn't need it or is even illegal, for instance, in the US, it's still legal to have it in the UAV. We removed it for our UAVs we have in the US. But we're more than willing to see also where the regulations are going. So if you have also any inputs here or any suggestion, or we can work on some projects together, we are more than welcome to see that. We have monthly roadmap meetings in which the sales, in this case, my side with my team, we bring in all the information from the market to our engineering or to our design organization team, and they will consider them to also see, to plan them in the roadmap, how to implement the new regulatory requirements that there might be, depending also on the geography, because this is also true. It depends in which geography you are flying. You might have different regulatory requirements. But yes, please, if you have any inputs at this point, very willing and very welcome to go more through in details. And very happy to hear that you have been working with the super artists. They've done a lot of interesting projects in the past. And we had them actually there for some small maintenance after 5 years. They purchased them, so it's a very nice machine.
Okay, thank you very much for the feedback. Yeah, I do say again, it is a terrific machine. Thank you.
Thank you.
So another question is, when you are doing Powerline inspections, so there is a lot of precautions that need to be taken because of the ongoing powers in the lines and even the high EMI induced by them. So what are the fail-safes that you are adopted for those?
It's also a very good question. Thank you, Amit. So this was very interesting. The first time we did that, it was one of the first time. When we did it ourselves. Our customer is doing that in China since 3 years already. They're flying BVLOS more than 20 kilometers, and they never had this problem. Also, they're flying around next to the 400 kilovolt power lines. So we did anyway a test in Switzerland for the electromagnetic compatibility, where we simulated the 400 kilovolts, and there was no problem on the autopilot and all the safety features that we have in the system. So from that perspective, there is not really something to worry about, I would say, or to be afraid of. One thing that we for sure do is keeping a safety distance while flying. The customer who requested us, they want to fly at least 20 meters horizontally away from the towers and the cable, and 10 meters higher. In that case, we say, okay, for the first time, we want just to keep more safety. We did 30 meters and 20 meters, 30 meters horizontally and 20 meters higher. And in that case, we kept safety. And in fact, the whole mission went smoothly, and there was no interference also from the 400 kilovolts, so the highest one that we have anyway here in Europe. There was no problem.
Thank you, sir, for answering. So I would request Dr. Ruchi to take over.
Thank you so much, Luca, for being a part of a conference. It was a pleasure having you at the conference, and we hope to really keep listening from you more often. And we got introduced to you today, and so supportive of you to come and take over the presentation today. Thank you so much. It was a very interesting presentation.
My pleasure. Thank you very much also.